AB Cactus 8 BC, Unit 5, Day 6, Office Hours. These are the answers to the worksheet, which hopefully you've already done, and check your answers. So here they are, though, real quick. Pause the video if you want to see them. Pause the video, check your answers if you haven't yet. A few more in the back. All right, so let's try these out. This is using our new integration technique called integration by parts. It's a reverse product rule of sorts. So all of these are products, and so we're kind of undoing this product. There's a sort of a checklist for Lipit. I would write this next to each problem. You might, if you need to, L is for log, I is for inverse trig, P is for polynomial, E is for exponential, and T is for trig. So, all right, and it's UV prime. When you integrate it, you get UV minus VU prime. That's the pattern. I try to remember the pattern more than the letters. Like, it was difficult for me to try and write that down from memory, but I could still do these very well without that. So the first thing I do is I just write Lipit next to each one of these, have sort of visual checklist. This is Poly, and this is Expo. So Poly and Expo. Now there's a shortcut that works for Polyexpo or Polytrig, so we can do the shortcut. You don't have to. And this is a one-step one, so it wouldn't be too bad to do the regular way, but this is still faster. So the thing that you take the derivative of that eventually goes to zero, that's the one you want to do that. And the other side, you integrate. So that's going to be e to the x, e to the x. You also need to remember plus, minus, plus. So there's an alternating sign to each line, starting with the positive, and then we multiply with a diagonal down. So the answer is going to be positive x e to the x minus e to the x, and of course don't forget the plus c. Done. That's a lot faster than doing it the regular way. You can do it the regular way. It works, but shortcuts helpful. Okay, number 2, we have Poly and Trig. So it's Lipit, right? So we have Poly and Trig. We can do the shortcut, Polyexpo or Polytrig. So I would, x derivative of x is 1, derivative of 1 is 0. You want to go all the way till you get a 0 with the thing that should go to 0 and take a derivative. Otherwise, you're doing the wrong one. Integrate this side. So the antiderivative sign is negative cosine. Antiderivative of negative cosine is negative sine. Plus, minus, plus. Multiply to diagonal. So this is going to be negative x cosine x plus sine x, negative times a negative, plus c. Shortcut. All right, next one. This is Polylog. So Lipit. Polylog, no shortcut. The thing first on the list should be your u. So the log should be u, and the other one should be v prime. So u equals natural log of x. V prime equals x dx. So the dx should go to the derivative. We take the derivative, we get 1 over x dx. This one I'm going to integrate. I'm going to get x squared over 2. So we're going to write it in here. It's going to be uv, 1/2 x squared, natural log of x, minus the integral of the two new things right here. I'm going to put the 1/2 out in front. And you have x squared over x, which is just x to the first. And you should be able to integrate this. That's the point of this. Because you guys can't integrate any of these without this method. So you mean minus 1/2 x squared over 2 plus c 1/2 x squared natural log of x minus 1/4 x squared plus c. There you go. All right, next one. Can you integrate this any other way? Nope. Something to think about in the future because we'll want to do it otherwise if you can. Lipit, we have poly and inverse trig. We cannot use the shortcut. The first thing in the list is your u. The other one is v prime. So u equals inverse tangent of x. V prime equals x dx. So we can take the derivative of u and get 1 over 1 plus x squared dx. That should have the dx. You can't integrate inverse tangent. So if you accidentally mixed them up, it should be obvious. This one I'm going to integrate. It's going to be 1/2 x squared. So it's going to be uv 1/2 x squared inverse tangent of x minus the integral of the two new things. I'm going to put the 1/2 in front. We can get x squared over 1 plus x squared dx. How do we integrate that? U-Substitution? No. Ooh, I can't do partial fractions because the degree of the top and bottom are the same. So I think we should try long division. X squared plus 0x plus 0. X squared plus 0x plus 1. Divide, get a 1. 1x squared plus 0x plus 1. Subtract, get -1 for the remainder. So it worked. Minus 1/2 integral of 1 minus 1 over the original denominator. That's what you do with the remainder. So we get 1/2 x squared inverse tangent of x minus 1/2 x plus 1/2 inverse tangent of x plus c. There you go. All right, next one, we have Polyexpo. Lipit. Polyexpo, shortcut. Take the derivative of the one that's eventually go away. 2x, 2, 0. Integrate the other one, e to the x, e to the x, e to the x. Positive, negative, positive, negative. You start with this first one, down a diagonal. This is going to be super fast. It's going to be x squared e to the x minus 2x e to the x plus 2 e to the x plus c. That saves you a ton of time compared to doing it the normal way because you'd have to repeat it. You'd have to do it twice. Okay, next one, Polyexpo. Lipit. Polyexpo, we can use shortcut. This is going to be repeated 3 times to eventually get rid of that. So this shortcut is super helpful here. 3x squared, 6x, 6, all the way down to 0. Integrate this side. Now be careful. It's going to be e to the 2x, but you need a 1/2 in front. It's going to be e to the 2x, you need a 1/4 in front. It's going to be e to the 2x, you need a 1/8 in front. It's going to be e to the 2x, you need a 1/16 in front. Because the whole chain rule thing, you got to reverse. Positive, negative, positive, negative, positive, diagonal, tick, tack, toe. All right, and the answer is 1/2 x cubed e to the 2x is a good order to write those, minus 3/4 x squared e to the 2x plus 3/4 x e to the 2x minus 3/8 e to the 2x plus c. That saved a ton of work. Next one to save you more. We have Polytrig. Lipit. Polytrig, shortcut. Polyexpo, Polytrig. This is, you're going to take the derivative of this one, and that's how you're going to integrate. It's not always whatever's first. This is the thing that's, if you take the derivative, it should go to 0. 4x cubed, 12x squared, 24x, 24, 0. Integrate the other side. Antiderivative of cosine is sine. Antiderivative of sine is negative cosine. Antiderivative of negative cosine is negative sine. Antiderivative of negative sine is positive cosine. Antiderivative of cosine is sine. Positive, negative, positive, negative, positive, negative. This one you would have had to do 4 times repeated the normal way, and it would have taken so long. Okay. So what are we going to get? X to the 4th sine x, right? Plus 4x cubed cosine x. Let me go down the diagonal. Okay. So we do that one plus minus 12x squared sine x minus 24x cosine x plus 24 sine x plus c. Don't forget the plus c. That's a horrible way to lose points after doing all this great work. There it is. Shortcut. Okay, got a few more on the back. So this one got to get creative. We don't know how to integrate natural log of x. That is not one of the rules we memorize. It's not one of our x. We're on the wrong way. But if we want to use this trick, we got to imagine there's something in front of it. So I'm going to say there's a 1. I'm going to call it Polylog. So Lipit, Polylog. No shortcut. Whatever's first on the list is your u. Next one's v prime. So u equals natural log of x. V prime equals 1 dx. U prime equals 1 over x dx. V equals x. It's going to be uv, x natural log of x. Looks better than natural log of x times x. That's weird. Minus the integral of the two new things, which is just going to be 1. Right? The x's are going to cancel. So it's going to be x natural log of x minus x plus c. Done. I mean, I guess we could memorize this formula. Don't. Please don't. It barely ever comes up, and you'll get it wrong. I don't want you to memorize it. If you try to memorize it for this test, I'm not going to give you points for it because I want to know that you can do it in the long term. If you memorize for this test, there's no way you're going to know it a month from now. Okay, now the next 2 problems are kind of tough, and I didn't really, I hadn't really done any like these. They are kind of like repeated use, but so I'm gonna add this to our notes first. Okay, so I want you to maybe get your notes from yesterday, or just get a separate piece of paper, and I want to do an example before we do these. Okay, and then I would like you to try these after the example before you just watch my video on how to, because I guarantee I'm put one like this on your next test. So you better know how to do it. And they're kind of difficult. So some quick notes. If I can find one, I don't know. Let's see. We might just do one of them because I'm not having success here. So, all right. We'll just do one of them, okay? And then you can try the other, and then they're going to come up on future assignments. So, I'm not going to do the notes, I guess. Thought I had something ready, but I don't. So, okay, here's the way it works. I'm going to start normal. I'm going to say, all right, this is Expo, and this is regular trig. So, Lipit. We have Expo and regular trig. That is not a shortcut. The only way a shortcut works is if you repeatedly take a derivative of one of these and eventually get 0, and that's not going to happen. So always has to involve poly. So the first thing is your u, the other one's your v prime. So u equals e to the x, and v prime equals cosine 2x dx. So everything's normal so far. We're going to take the derivative of u, we're going to get e to the x dx. We're going to integrate v, and we're going to get v equals 1/2 sine 2x. Okay? Everything's going good. Now we're going to write it. uv 1/2 e to the x sine 2x minus the integral of all the new stuff. I'm going to put the 1/2 out in front. And it's going to be e to the x sine 2x dx. Okay. Now, sometimes when we do this, we're like, well, I can't integrate this. I guess I got to do it again. All right, let's do it again. We got expo and trig. So very similar to last time, expo and trig. Expo should be your u. The trig should be your v prime. I'm going to set up new ones. U equals e to the x dx. V prime equals sine 2x dx. I shouldn't put the dx in. All right, cool. Well, let's take the derivative of this. It's going to be e to the x dx. Integrate this. It's going to be negative 1/2 cosine 2x. All right. So let's write down what we have now. We're going to have, okay, 1/2 e to the x sine 2x still. And then minus, I'm going to put this all in parentheses. I got to distribute this negative 1/2, okay? I'll do that later. uv, so we get a minus 1/2 e to the x cosine 2x, okay? Multiply it minus the two new things, which has a negative 1/2 I'm going to put in front. E to the x cosine 2x dx. Okay? Now, hopefully, what should be happening is that this second integral is getting closer and closer to something we can actually integrate. Oh, man, I can't do that. Does anyone feel like we're going in circles? Like this is never going to end? You're right. It's never going to end. In fact, look at this. This is exactly what we started with. It's not going to end. But here, let's use this, okay? The fact that this is what we started with, we can use that to our advantage. So if you get caught in one of these, you want to keep going until you get what we started with. Because check this out. I could say, all right, let's rewrite this. We're going to say e to the x cosine 2x dx is what we started with, right? And so far we have 1/2 e to the x sine 2x. You got to distribute this. It's going to be plus 1/4 e to the x cosine 2x. And then it's going to be minus, that's going to be plus, so it's going to be minus 1/4 integral of e to the x cosine 2x dx. Okay, so I just rewrote what we had. Okay, what we started with, what we have so far. Now, the fact that these are the same, this is a cool trick. This is a really cool trick. We're going to add this guy back over to the left-hand side and combine it with the original problem. Check it out. This is cool. It's sneaky. We're going to use this, okay? That means this is 5/4 e to the x cosine 2x now, right? The thing we're trying to find is this. And just rewriting what's left over on the right. So check that out. We moved this guy, we got it to match it, moved it over here, combine it with this, and this is what we want. So let's just multiply both sides by 4/5 now. And now we have isolated, that term. And we got to distribute this, and we got to remember to put plus c. So this is going to be 2/5 e to the x sine 2x plus 1/5 e to the x cosine 2x, and then you need a plus c. Boom. You did it. I mean, still hard, but kind of cool trick, right? So hint, number 10 is similar to that. I want you guys to try number 10. So stop the video and really try number 10 first, because I'm going to put one like this on your test. And if you haven't really tried it, practice it a good amount of times on your own, you're not going to get it. So pause the video, stop the video, try it, and then I will go over it at the end of this video right now. Okay, I'm assuming you guys tried it. This is Expo. This is Trig. We can't integrate any other way. We're going to try integration by parts. Lipit. We have Expo and Trig. No shortcut. First thing should be your U. The next one's your V prime. So U equals e to the 2x. V prime equals sine 3x dx. So we got to find U prime, and it equals 2e to the 2x dx. We got to find v. V equals negative 1/3 cosine 3x. Let's be good with our antiderivatives. So we're going to write it uv negative 1/3 e to the 2x cosine 3x minus the integral of the two new things, which has another minus 1/3, which I'm going to put in front. I'm actually going to put 2/3 e to the 2x cosine 3x dx. And we realize we're going to get in this kind of endless loop. So our hope is let's go as far as we need to get this to match with that, and then we'll use that trick against it. But we're going to have to do it again. So this is Expo. This is Trig. So Expo should be the U. Trig should be the V prime. This is a new U. U equals e to the 2x. V prime equals cosine 3x dx. Okay, so U prime equals 2e to the 2x dx. V equals 1/3 sine 3x. Okay, so we're going to write it. It's going to be negative 1/3 e to the 2x cosine 3x plus 2/3. Now all the new stuff is going to be in parentheses, so be very careful. There's a lot of easy mistakes to make. UV 1/3 e to the 2x sine 3x minus the integral of the two new things. I'm going to put the 2/3 out front. E to the 2x sine 3x dx. Now here's the good news. This matches this. So I'm going to move this over to the other side. Now we got to distribute this too. I'm going to go ahead and kind of try and do that at the same time if you guys feel comfortable with it. That's a negative 4/9. So I'm going to add the 4/9 to the other side. And 4/9 to 9/9 is 13/9. So I'm rewriting it. I'm moving this to the left side. Okay, and then it equals negative 1/3 e to the 2x cosine 3x plus 2/9 e to the 2x sine 3x. You could write the plus c right now, but don't multiply. Don't leave the c with that multiplied in front. So now to solve for what we need, we're going to multiply by 9/13. 9/13. And so the final answer is the original problem, e to the 2x sine 3x dx equals negative 3/13 e to the 2x cosine 3x plus 2/13. You got to distribute this. E to the 2x sine 3x plus c. Don't write 9/13, just plus c. It works. You did it. Those are kind of crazy problems, but I'm going to give you something like that in your next test. So make sure you're confident that you guys can do them yourselves.